Welcome to this session, and in this session we are going to discuss the interfaces in Java programming, right? So now before we talk about interfaces, so let me give a brief about abstract class, fine? Because you need to know what is abstract class, so before you can bring in the interface concept in your Java programming. And in that term, so when I talk about an abstract, it is what the abstraction what we all discuss about Java programming, and we say it's one pillar of the Java programming and the main key concept of any object-oriented programming. Hence, when I say abstraction, we are going to hide few details for the user. So we are not going to say how the system is going to work. We'll just say what the system is. Something like when I create an object, we will just say what is the object, how to use the object, rather than saying how the object has been implemented. Hence, we hide few certain implementation details at the abstract level itself, and that is what we call this as an abstraction. And you know how to define a class, you know how to declare a class. So when you're aware about how to you make use of a class, now we just have some sort of information about abstract class. So now whenever we are going to have a class, just look at this. This is an as usual class what we are doing all these days. So we were just going to define a class called a shape, which has got a color, which act as a variable to store in color value, and I'm going to have two methods called as void color and void draw as in data members or a member functions. Hence I'm going to have data member as well as these two member functions. And now I'm just going to have a class demo where I'm going to create a new object for this class, and I'm going to access these two methods. And this is as usual the program what I'm going to get, and when I execute this, I'm just going to get the output as I am red and let's draw upon calling these two methods. Hence it is as usual the same class or abstract class what I'm going to implement. So now just look at this program what I have been modified now. Now rather than calling this as a class, now I'm going to call this as an abstract class. Now when I say it as an abstract class, now both are not same. Clearly understand this. This both are not same. Now what difference it makes? The major difference is whenever you're going to have an abstract class, you're not supposed to create any instance. You're not supposed to create any instance for this class. If it is an as usual class, you can create the object. But once you're going to make it as an abstract class, you cannot create such instances. Hence, for if it is going to be a class, you can create the instance for this class or the object of this class. But once if it is going to be an abstract class, you are not supposed to create any instance or any object for this class. The first major difference between a class and an abstract class. Hence, we are not defined any object, hence you cannot call the color, and even you cannot color the draw function because there is no any object called as obj. This is what the first point is. The every abstract class what I am going to create is going to be objectless class. You cannot create any object for this class. Now what is the use? What is the use if I am going to have an abstract class and I am not going to create an object? If there is no object, I cannot make use of the color method, I cannot make use of the draw method, and I cannot make use of the color. Yes, you cannot use this at this point of time. When I say abstract class, this is going to hold all the abstract information in the form of method or in form of detail. If you want to make use of this abstract class, then you should do something like this. You need to extend, you need to have the inheritance concept. We'll make the abstract class a super class right now, and we are going to create one more subclass called as square. Now I'm extending this shape. Now this shape, which is a super class right now, it is going to be abstract class, and the square which I have just created as a subclass is the non-abstract class now. And so now for this square, I can create the object. So I cannot create the object for the shape, but now I can create the object. By creating the object, I can call this methods now. So now this job I would have done at the earlier stage. The same output I would get without making use of abstract and even without making use of extend. But what's the use? Still, what is the use of making a class as abstract? Just look at the example what I have been modified now. So now I'm just going to have an abstract class shape, and now I'm going to have the same methods and extending. Now just look at this particular statement here, what difference I'm creating here over now. So if you remember in the earlier sessions of this Java programming, I told you that the superclass object as a reference variable can hold the address of the subclass objects. That is what we are doing here. So now shape is a superclass, square is a subclass, and the object reference of a subclass has been saved in the reference object of a superclass. So now I'm going to use color and draw the same. I'm doing it the same operation where I'm going to get the output as still as I am red, and let's draw. But still I am assuming, or still I am asked on what is the use of abstraction or abstract class. We'll go further now to understand the difference. So now we are just going to have the same class, the same program what I've explained with the superclass object and the subclass object. So now just look at this difference now. I'm going to have abstract class. Now just have a look at this particular method now. Here we had draw method which was an as usual member, and right now we are going to call this as non-abstract method, where the color was non-abstract method and even the draw was also a non-abstract method. But now in this case color remains non-abstract method, whereas the draw function or the draw method becomes an abstract now. And now just look at this point. As soon as I make a method to be an abstract method, we are not supposed to do such operations. That is, we are not supposed to have any body for the abstract method. It is something similar to the class. If it is an abstract class, it won't have any object. If it is an abstract method, it should not have the body. Fine. If it is a non-abstract, it can be defined with the body and it should be defined with the body. Whereas if it is an abstract method, you're not supposed to define any body for this method. Hence, I am moving towards the advantage of making use of abstract now. So hence, so now you are not supposed to define the body. Hence, we will debug this and we are going to remove the body of this draw method. So now, if this void draw doesn't have a body, then who is going to have or who is going to define the body for this function? As now, the body for this function will be defined by the subclasses or the class which is going to extend the abstract class. And so now using the abstract concept, I have abstracted the class to have without any object and the abstract method to have without any body. So now body for this method will be defined by the extending class. And so now we are going to have void draw and I'm going to have I am square. So the body of this I am just going to put into the subclass now. So now when I execute this program, I am going to create the object of the square and I'm going to assign the reference of this square for the superclass object called as shape. Now if I execute this operation, what output I'm going to get? For the color I'm going to get as I am red, and for the draw function there is no body for this, hence the body of the subclass will be used and I'm going to get the output as I am square. Fine. So now still I am confused, what is the use of this? What is the use of still this abstraction? We'll go further with the example now. Now in the further example, I am going to have two subclasses using the same superclass as the shape. I am going to have square, extend shape, and the circle, extend shape, and just observe the draw function is still an abstract method without any body. Now just observe, the draw has been defined in the square function with its own implementation, and even the same draw function has been defined with its own implementation of the circle subfunction. Now one function what I add in the abstract class, using that as an abstract or that as an interface, I have been defining different bodies for the same function in different subclasses. Fine. Now this is the power of using an abstract class and abstract method. Same body, that is the same header, same definition, same prototype, same function signature. Now as a different structured body strictly we are going to have. Fine. So we will see further what else we can do with the abstract class. So now if I execute this program, I am creating the object for new square, I am creating the object of the new circle, and I am creating the object reference of the superclass itself. Hence when I execute this, I should get the output as I am square and I am circle. Hence I am going to get this as the output. So now we'll go further and we'll see what is more advantage of using an abstract class. So now just look at this. When I am going to have this as the program and I have been modified that I am just going to have void draw and I am going to have a body for this function now. The same program, I am going to have a body for the draw function in the superclass, a body for the draw function in the subclass, and as well as in this subclass. So now the same statement, I have not changed anything in the main function. So now when I execute, what is the output I am going to get? I am going to get the output as I am unknown and I am unknown. Now this is due to I am going to have a body of the function where the shape would have been drawn. Now depending upon the object what I am going to use, and using the same draw function, I would have drawn different shapes, but I am using the body in the superclass itself, hence I am not able to get different shapes. I am going to get unknown shape now. This is what the abstract class is going to do for you now. So instead of having a common body for all the subclasses, so now I am going to have different body for the different subclasses by making a method to be an abstract method. And so now we are going to make this void draw method to be an abstract method. And still if I want to get the appropriate output, then I cannot use the superclass object as a reference. I need to use the object of the same subclasses if I want the output. If I want to call the draw function from the superclass, then this is not possible right now. If it wants to be possible, you need to bring in the concept of abstract method and you need to solve this. Hence, that is what I am just going to make the method as to be abstract now. And I'm going to start extending all these functions what I was doing all this time. Fine. So now when I'm going to do this, just look at this. I'm just going to have an abstract void draw method, and now when I execute this program, I'm going to get an error over here. And the error why I'm getting here is because you cannot have an abstract method if the class is not abstract. Unless you don't make a class to be abstract, you cannot have an abstract method. So just keep this point in your mind. And so now this is what a abstract class and the abstract method is going to be. Hence we can achieve the abstraction in your Java program using the abstract class and using an abstract method. And at this point of time, I hope you have clearly understood or at the abstract level you might have understood what the abstract class is going to do without a object, which is going to allow me to have abstract method. If I'm going to have a abstract method, then for the same method I can have different types of body or different body structure. Fine. It is something what different than the function overriding. In the function overriding, the signature will be similar, body can be defined or body may not be defined for your class, for your up methods. But if it is a function overriding, so the body of every method should be defined. Even for the superclass, the body should have been defined. Even for the subclass, the body should have been defined. But once you make it as abstract method, you need not. You can avoid the body of the body of your superclass. Hence, this is the power of abstract class and abstract method in your Java program. Now, when I talk about abstraction, we say abstraction can be achieved in two ways Java program. The one way is making use of abstract method and the abstract class. The second way is interface. Fine. So now what is the difference between this? Anyhow, these two are used to achieve abstraction in your Java program. This is the similarity. What is the difference? Why I got two different mechanisms? The two mechanisms are because the abstract class and the method will give me partial abstraction. So when I say a class is abstract, inside the abstract class, I can have few methods to be abstract and few methods to be non-abstract. Fine. But whereas in the interface, it is fully abstraction. Once I am going to create a interface, all the methods what I put in this interface now should be compulsorily no body methods. Clear? This is what we say it as full abstraction. So now we will see what the interface is going to do all about. Hence, so the interface is the one which is going to fully abstract a class interface from its implementation. This means none of the class, method or none of the members of the interface what I am going to use now will not have any body. It will just have only declaration, and the implementation or the definition of all those methods should happen in the class which is going to inherit those interfaces or the classes. Fine. So now in this interface, so what we think about is we'll just see what a class must do but not how it does. Hence, every interface will just declare a method. It will never bother about how the method should be implemented. That is what we say class must do, but not how it is going to do. And so now it is similar, the interface similar to classes. It is similar how we are going to define a class. Similarly, we are going to define an interface, but lacks instance of it. So similar to as it is similar to abstract class now. If it is abstract class, we cannot create any object, we cannot create any instance, and this is what it happens right now with this interface also. If I declare a class, you can declare an object. If I declare an interface, you are not supposed to create any object for this interface, similar to abstract class. And so all the methods, whatever I am going to now put inside the interface should not have any body. Clear? It should be just a function declaration. That's all. Fine. And so now with this, so any number of classes can implement an interface. Once I create an interface, now this interface can be used by any number of class. Clear? And one class can implement any number of interfaces. Fine. I'm going to have one class. Now this one class can have the properties of first interface, second interface, third interface, any number of interface. This is what we call this as multiple interfaces. Fine. And if you just go back and think about the inheritance in the Java program, multiple inheritance is not possible. I cannot have one subclass which is going to inherit the property from more than one superclasses. But in interface, one interface can have the property of more than one interface. Hence, multiple interfaces possible in your Java program, but multiple inheritance is not possible in your program. That is what we say, one class can implement any number of interface. Hence, if you are looking out in your Java program that you need multiple inheritance, you can achieve this using multiple interface. Clear? This is what I have just put over here. So if it is an inheritance concept, you cannot have a class which is going to inherit the property from two or more superclasses. But whereas an interface can be used by two or more class, and an class can be used with two or more interfaces. This is what we're going to talk about interface in Java program. And when I'm going to have an interface, and whenever a class is going to make use of an interface, keep this point. Every method of interface is going to be bodiless. It doesn't have any function body, remember this. So this means now the class what is going to make use of interface is responsible to define the body for all those methods. This is what we say, a class must create the complete set of methods defined by the interface. It should define all the methods what the interface ABC is going to contain from the class XYZ. Clear? So now it applies for the other class also. So this class should also, now if the interface contains three methods, it cannot take a choice that I will be declaring one method and the other class can declare two methods. There is no such choice. The class XYZ should implement all the three methods, as well as this EXP should also implement all the three methods. Hence, we say complete set. Each class have its own implementation, what just have been told. And so this is something where we talk about polymorphism. Fine. That is one interface. We are going to have multiple methods. This is what again was happening with the abstract class. In abstract class and abstract method, I had one method definition. I had multiple different body for this same method. That is one method, multiple definition. Hence one interface, multiple methods. Almost the interface and the abstract are similar and the same, but the difference is every method in the interface should be no body. Whereas in abstract class, you can make a choice which method should have body and which method is not going to be with the body. Hence, that is what we talk about polymorphism. So now we'll just see how exactly we are going to define an interface. And so now we are going to have a new keyword called as interface now. Fine, using a new keyword interface, we are going to give the name for the interface, and while giving the name for the interface, we are going to specify what is the access specifier is going to be. That is, whether it's going to be public interface, it is going to be default interface, or a private or a protected. And this interface, as I told you, can contain list of methods. The methods can be data member or the methods can be the member function. Hence, if it is going to be a member function or method, the method name, return type, parameter list. As usual, what you are doing all this is in the class. And we are going to have a data member. We are going to say what data type and the variable name and initialize the value. Now just look at this. This is the one major difference what I can look at right now with respect to an interface and a class. Fine. So if I'm going to talk about a class, I'm going to have method, and the method should have a body. Either you define the body of a method inside the class, or you're going to define outside the class using scope resolution operator. But if it is an interface, you are not going to define any body for this. And if it is a data member in the class, You are not going to initialize the data member. You're not going to initialize the data member. You can initialize only if it is a static data member. But now, whatever the data member you are going to declare in the interface will be the final data member. That means it is going to be a constant data member. You need to initialize this because it's a constant. Whatever the value you initialize for this variable or data member of the interface, it will remain constant. You cannot modify this value throughout the program. You can just use this, access this. You cannot supposed to modify this or change this. Fine. So similarly, I can have any number of methods. I can have any number of data members, and all this data members is going to be final data member, so which is equivalent to constant value or constant data members. Fine. Hence that is what we say when I'm going to have an interface. Access specifier can be anything, starting from public, private, protected. Even this can be default also, and you know what the default keyword is going to do or what default specifier does when I'm talking with respect to packages. Fine. So now the keyword we are going to use is interface to create any interface, and every body should have no body. Every method should have no body in the interface, and the data members are always by default or final, or we can hear as constant, and even these are static data members. Hence we are going to initialize this. By default, all the data members of the interface is going to be final and static. So keep remember all these points. So hence all the data members should be initialized, and all the members by default of an interface are public. You cannot decide what this member is going to be or what data member is going to be. By default, all the members are public. It is not by just default. It is strictly every member should be public. Hence, you cannot use access specifier for any member of your interface. So this is what you should know when you're defining an interface. So once you have been defined an interface, how to make use of this? If it is a class, you can create the object for the class and you can use that class. If it is an interface, you are not supposed to create any object for the interface. Then how you are going to make use of this interface then? That is what, once you create an interface, the next immediate step is you need to use this. That is what we say implementing the interface. And at this point of time, clearly understand the keywords what we are using. We had used extends keyword for creating an inheritance. Whenever I want to create subclass from a superclass, I am going to use extends keyword. Remember this. And the interface keyword is used to create an interface. And the implement is the new keyword again introduced to you right now whenever you want to implement an interface. Now, for example, just look at this syntax what I am using here. I am going to create a class now, and whatever the class I am going to create now, it can make use of inheritance using a extend keyword and using a superclass. It can extend. At the same time, it can implement a interface also. Hence, I am going to use the keyword implements and I am going to give the interface. Now, when I am talking about inheritance, any class can have only one superclass. Hence, you don't think about using comma here and making use of few more superclasses. You cannot do this here. But implements, you can use comma and you can use any number of interface because multiple interfaces allowed in your Java program. Hence, whatever we have put in this square brackets is optional. The class can extend, class can implement, and it's going to have its own body of the class. And just look at few examples. I'm going to have class demo. Now this class is not part of inheritance. Even this is not going to implement any interface. And just look at this example. I'm going to have interface iDemo That is, I'm creating a interface now, and I'm going to have a set of statements which is going to act as a body, and I'm going to have class demo implements idemo. That is, now this is the class demo I'm creating, which is going to implement the interface. Hence we are going to have implements. Hence now whatever the method this interface contains, all those methods this demo class should implement. Fine. And so now we are going to have class demo, and I'm going to have demo extends as demo. Hence I'm talking about inheritance now. This is implementing the interface, and this is implementing the inheritance using extend keyword. And so now this becomes superclass and this becomes subclass. But here now you are not going to call this as superclass and subclass. It is just implementation of the interface using the class demo. And we are going to have interface, and we are going to have a class, and now a demo now can extend an class as demo, and even it can at the same time use the interface as idemo. That is what I am using extend, even I am using interface, which is going to implement. So we are just going to have the class demo which is going to implement. So please make a correction here. This is not interface, this should be implements. So this is going to be implements. I'm going to use the keyword implements here. I made a mistake here, so please note down the correction. And now as I told you, the class can extend only one superclass, but it can implement n number of interfaces. Hence I'm going to have the interface 1, I'm going to have the interface 2 as idemo and jdemo, and I'm going to implement those two. Again, the same correction you need to make here. So this should be implements, not interface. Now this is how we are going to implement an interface in your Java program. And this interface idemo is going to be declared with one member function, which is going to be as display, and I'm going to have a demo class, so which is going to implement the idemo, that is the idemo as the interface. Now this is display function which should be implemented in this class, and whenever we are going to implement any method in the class of the interface, it should be public. Hence the interface method to be implemented, which we are going to implement, should be public only every time. So just note down this one point. So now whenever you're going to talk about any class which is going to implement a interface, so it need not that it's going to implement only the methods of interface. It can have its own method also. So something, now we call this method as the interface method, and now this is its own method of the demo class, which is not part of interface at all. Hence we call this as non-interface method. Hence, so whenever it's going to be an interface method, you need to specify it as public member. When it is not, you are left with the option. You can use public or default or protected or private of your choice. You can do it of your choice. Hence, this is what you should do when you're going to implement an interface inside a class. So now, when you're going to have an interface, you're not supposed to create any object for this, but you can create a reference of interface and make use of the object of the class which is going to implement it. Now, for example, just look at this program now. Now in this program, in the class exp, the main function, just look at this, idemo is the interface. So for this interface, I am creating an object reference. So remember this, here I am not creating any object for the interface or any instance for the interface, because I am calling the constructor of the demo class. Hence I am creating the object for the class demo, not the object for the interface idemo. Hence, so the object what I have been created, this I am going to initialize or I'm going to store the reference in iDemo. Now just recall again, the superclass object can hold the reference of subclass. The same mechanism has been used here. And so now using this object, I can call the display function. So which is going to execute this statement. So being an interface reference, I am calling the body of the class which implements it. So this is the power of using interface again. And now, so the object is going to be in reference of interface, and so now this can call only the methods which it has been declared. Now it doesn't have any authority to call the put function which is not part of interface and which is a non-interface method. Hence you're not supposed to do such statement or call the method which is going to be non-interface method. This is what you should remember when using the interface as a reference now. So now when I'm going to have an interface shape and I'm going to have a square which implements shape and I'm going to have its own function. Now just look at this. This is what I had taken the same example when I was discussing about an abstract class. The same thing I'm going to do here. I'm going to have no class exp and create the object 1 for the shape, create the object 2 for the circle, and I'm going to say object 1.draw. When I say object 1.draw, just look at this. Object 1 is the reference of the interface shape. Hence, when I say object 1.draw, so right now object 1 is holding the reference of the square class. Hence, this draw function will be called. So though this draw is shared between these two classes, but right now your shape interface object is referencing the object or the memory or the object of the class square. Hence this draw function will be called and I'm going to get the output as I am square. And just look at this statement now. I've created the object 2 which is going to be the object of the class circle. Now I am initializing the reference of the object 2 as the reference of the shape object 1. So until this point, the object variable, the reference variable of the interface was pointing at the square object. Now it's going to point at the circle object. The same similar statement, this statement I had called this draw function, the same statement is going to call the draw function of the class circle. This is the power of using an interface in a Java program. Hence for this reason, I am going to get the output as I am square. For this statement, for the same similar statement, I am going to get the output as I am circle. And this is how we are going to use the interface. So when I talk about the implementation, I told you that the class which is going to implement the interface, it should have the complete set of the definition of all the methods of the interface. Now just look at this interface. It has got two methods, but just observe now. This class is implementing the shape, but it is defining only the body of the draw. Now what is the body of the color is going to be? Who is going to define this? So none. Even the interface cannot do this. Even the square is not doing this. In this scenario, that is where you're going to get a syntax error. This is not the right way of doing this. If still you think that you don't want to define the body for the color, and that is where we talk it as partial implementation. It is possible to have partial implementation in Java program, but if you make the class as an abstract class. So just recall, the interface is going to give me full abstraction and abstract is going to give me partial abstraction. And so now we are going to have this program which has been debugged. Now this is going to work fine. But look at the problem. If it is an abstract class, you cannot create an object. Now you need to extend this class, and at least in that extending class, you need to make sure you're going to put the body for the method color. And this is how you're going to look into partial implementation of an interface. Now if I talk about the nested interface, so an interface now can be the member of another interface, or can be the member of another class or a class. That is what we talked about nested interface. Hence the interface which I'm going to put inside another class or another interface, we call this as member interface, or this also can be called as nested interface. So the nested interface now can be public, can be protected, or it can be private. It can be of any access specifier, and even this can be default, or this can be any of the protected type. But if it's a top level interface, what we have discussed until now, if it is not a nested interface and if it's a top level interface, it can be only public or default. The access specifier should be only public or default. But if it is a nested interface or a member interface, it can be private also, it can be protected also, but not default. It cannot be default if it's a nested interface. So remember this point. Now for example, I'm going to have class demo interface shape. Now inside this class, I am defining an interface. Now this interface becomes the member interface or nested interface for the class. And so now when I'm implementing this, you need to quantify this. You need to qualify this shape interface. Now I cannot just use this as a shape because the shape is inside the demo class. I need to refer through this demo class itself. Using dot operator, I need to qualify this. Is it fine? Hence I'm going to have void draw, and I'm going to define the body of this. Once you are inside this, you need not use any more qualifying this particular method in this program. Fine. So now I'm just going to have class ESP. Again, if I want to create any reference for this interface, again you need to qualify this. So this is what's similar to the nested class what we discussed. We're going to have in such a way you can have any number of levels of nested interface in your Java program. So now what about variables in interface? All these times we were discussing about the methods which is going to be in your interface. Now what about the variables in the interface? The variables in the interface, what you define, as I told you, by default they are public and they are final and they are static. Hence you need to initialize those values. Now the variables what I am going to use in interface can be used as a shared constant because it is static. It can be shared by any class, any object which is going to implement it, and it's going to be constant value which can be used throughout multiple classes. Something like the constant what I define in C and C++ program as a macro. Fine. Hence I can just make use of the data member in whatever the way you want, but I've just put a simple example here. But you are not supposed to change the value of this because it's a constant. You're not supposed to modify the value. That is what you should know about variables. Okay, now we'll just see how we are going to bring in the concept of inheritance along with the interface. Now just look at this. I am using the concept of interface along with the concept of inheritance. The two mechanisms I am bringing together now. So this means, so one interface what I have been defined, now it can inherit, another interface can inherit the property of this inheritance. And now just look at this. I am going to have interface shape which has got two methods, and I am going to have one more interface which is going to have one method. And just look at this. Now this interface is going to extend the shape interface. And so this is going to be the super interface and this is going to be sub interface. And so now whenever we are going to have such scenario, we are going to call this as inheritance of interface. So now when I'm going to have a class which implements a shape, now how many methods it has got? It has got two methods. The shape has got two methods. And these two methods should be implemented in this class. right now it is going to implement only one method, hence it is not allowed. It is going to be partial implementation and you need to make it as abstract class, or else it should implement both the methods. And if I am going to implement the color interface, how many methods it has got? Along with set, it has got three methods. All the three methods should be implemented, else you are going to end with a syntax error. Or if you are taking it as a partial implementation, you need to make this as abstract class. Right now I am not using any abstract in these two cases, hence you are going to end with syntax error in the both the case, because here you need to define one more method, that is erase. Here you should define two more methods, that is draw and the erase. That is what we are going to see it as syntax error along with this program. So now we are going to have the same square I have been implementing. Define the body of draw, define the body of erase, defined the body of set. It is a complete set now, and so I have implemented completely. This is how the interface can be extended or interface can be used with the inheritance concept. And this is all for this session. Thank you.